All right, let's do it. This is final review number 2. I'm here with a bunch of 8th graders that are currently taking the final and totally not listening in. Their earmuffs are on. And I'm also with our live studio contestants from freshman class. Mars, that's Mars, the scary one. And Kentucky, who is the one that sounds and looks like a chicken. So let's go ahead and take a look at test number 6 to review. Remember, if it's not on the test, it's not on the final. I didn't give you a 6. Here's a 6. But I did give you a 7. Where are the 6s? Hello? Didn't I give you 6s?
No.
Okay, well, here. Luckily, I printed a few extra. Here you go. Bye. Let's go ahead and get this done. Do we want to do the traditional? It seems to be that this is the case. Do we want to do the traditional, just go straight down the page until you tell me, hey, skip that one? Or do you want to go to specific ones? What's the thought? Fantastic. We are here and we don't know why. All right, so here's what I'm going to do. I'm going to go down the page and we'll skip them if you want to skip them. The class the other day skipped the first one, so I think it would be healthy if we started doing the first one. It says this is the ratio of our marbles. We've got 5 red, we've got 3 blue, and we've got 1 green. That means for every 5 marbles in the bag, 5 red, you're going to find 3 green or 3 blue and 1 green. They tell us there are how many red marbles in the bag? 15 red marbles, which means in reality, how many green marbles are we going to get? 9 is incorrect. I'm asking about green, not blue.
Oh, yeah.
We're going to get 3 because for every 5 there should be 1 of those. And what about blue, Kentucky? 9. Very good. Thank you. So in total, how many marbles are in the bag?
27.
Yes, 27 marbles. This is a team effort. 5/9 of the people in the town voted, meaning 4/9 didn't, right? 64 people didn't vote, so that means 4/9 of our population is equal to 64. I'm going to say that one more time just in case you were not paying attention. 5/9 voted, and we know 64 people did not vote. So that means 64 people must be equal to the 4/9 that did not vote. So 4/9 of our population didn't vote, right? And that's equal to 64. Let's solve for our population. You have options in this case. You can divide by 4 and make that a 1/9, and this will be a 16. Or you can times by 9. I know I don't want to times by 9, so I'm going to divide by 4 and get this. And then I'll times by 9, which is a much more doable number. Population is going to be equal to 16 times 9. What is 16 times 9? How are we going to figure that out? 9 times 10, which is 90, and 9 times 6, which is 54. Looks like 944. That's how many people are in the town. Skip 631. You estimate on this one, it's kind of silly. I don't like it, and it's not on the test or on the final, so just skip it. I'm visiting Slovakia. You better bet this one's on the final. It says my meal cost 10 euros, and I gave the cashier $15. I need to know what my change is going to be. Here's how I do it, okay? Here's how I do it. I take the $15 that I gave them, and I convert it to euros, which is what I should have done before giving them the money, right? That's just polite. But we're going to do it now. I need to divide by dollars so dollars goes away. Is this ringing a bell? Yeah. And I'm going to get euros. If only I knew the relationship between euros and dollars. 1 euro and $1.32. Yeah, it's important to read directions, right? Make sure you're matching those up. Well, if I give you this, right? Clearly one of these is positive and one of them is negative, isn't it? Well, if you don't change the sign, they're going to both be positive or both be negative. That doesn't make any sense. No, because then you didn't change one of the signs. So over here, we know the dollars are going to divide out, and we're going to times by 1 and divide by this. And this looks really, really awful, but it really isn't, because we just get this. It's okay. Deal with it, right? Just deal with it. What we're going to do is get commie denomies. We're going to take this, which is the amount of money we gave them, and subtract 10 euros from that. because that is how much we actually need to pay for this stuff. So here's what we gave them. We're going to subtract what it costs. Now, in order to do this, what do we need? We need commie-denomies. So what denominator do we need here? 1.32, right? Now, Mars, in order to get 1.32 on the bottom here, I'm going to have to times by 1.32 over 1.32, because otherwise I'll change the problem, right? So if I do this, all we got to do is take 10 times 1.32. That's pretty easy. What's 10 times 1.32? What happens when you times 1.32 times 10? 13.20 or 13.2. So now we can actually subtract these, right? We're going to get a gross answer, but I don't care. You're just going to circle it when you're done. We got to do 15 minus 13 and then take away another 0.2. What's 15 minus 13? Dose. And then we're going to take away 0.2, which means we are now down to 1.8 over 1.32 euros. This is the reality, right? It's never going to come out nicely, so what are we trying to simplify for, right? Boom, there you go. Done and done. So again, what you want to do is get commie-denomies and then just leave it? I don't know. All right, should we talk about percentages? Yes, no, maybe so. Christina's like, please, 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 talk about percentages. Yes, please, please, please. What number is 52%? What does of mean? What does of mean? Mathematically, of means what? Of means multiply. So yeah, you should definitely know what that word is. Of means multiply, just like is means equals. So you might notice that there's a really easy way to simplify this, isn't there? Wait, you can't see it? Oh, I'm sorry. There's a really easy way to simplify this, isn't there? We have the times by 52 and divide by 100. Which would you rather do first? This just becomes 3. And 3 times 52 is 156. Next one is what percent? Well, percent means per 100, right? So what percent? What does of mean? Of 150 means multiplication. Is, that's an equal sign, 66. How can we simplify this to make our lives better? We could definitely divide by 10 and 10, right? That's what I did yesterday. This gets us 15. We can definitely take out a 5, right? It says divide by 5 and divide by 2. Well, pause. This says divide by 5 and divide by 2, right? That's what divided by 10 is. So if I divide by 5, we're left with a 2, and this is a 3. And our life will be a much better. What can we do now to get x on its own? Multiply by 3 would make this a 9, which does not help. If we divide by 3, we're going to get x over 2 equals this divided by 3, which is 22. And at this point, you can probably tell x is 44. Yeah, x got to be 44. All of these are basically like, can you find a nice way to do this, right? That's the catch. Obviously, setup is key too. 255 is 85% of means what? What number is x? What do you negate to get 2 is what we're asking. You're correct. That is a good way of thinking about it. All right. What can we do to simplify this so we, don't puke all over the place? You definitely could, and that's going to make that giganto. I've got a better option. Let's go ahead and divide by 5, right? Isn't this divide by 5 and divide by 20? How many times is 5 going to 85? It goes into 50 10 times. 35's left over. It's 17. Right? 50 and 7, or sorry, 10 and 7, right? If you times them by 5, you're going to get 50 and 35. That's 85. At this point, 17 and 20 are as simplified as they can be, so I guess we got to times by 20 and divide by 17. I'd probably rather divide by 17 first if it works out nicely. And fun fact, it does. It would actually be easier probably to divide by 85, just so it's easier to count, but we'll divide by 17. Doesn't 17 go into 170, right? Which then means it would go into 187, right? And then it would also go into 204. It would also go into 221. It would also go into 238, and it would also go into 255. So the question is, how many times is that? Well, I'm going to write this down over here. That's 170. How much is left over? Well, 85, right? We just figured that out earlier, right? Isn't 17 times 5? So yeah, we need 17 times 15 to get all of that, right? So if we divide by 17, this becomes 15. Right? 17 times 85, it turns out, is 255. And then, of course, we can times by 20, which means we're going to double it and add a 0 on the end. We're going to get 300 equals x. If you get stumped on any of these ones, you can totally raise your hand, right? But finding the clever solution is really the goal here. Yeah, in this case, I probably would have divided by 5 to here and here. But yeah, that's okay. 4,000 divided by 2 is 2,000. So what's 4,000 divided by 20? Are we doing the mediums? How many gallons are in the pool? And how many gallons did you start with? And how many you're adding? It's going to take a long time. I'm fine with that, yeah. All right, looking here, Alice is growing sizes. So we need to keep track of her height. Height number 1 is her original height. And the ratio between height 1 and height 2 is 8 to 3. The ratio between her second height and her third height is going to be 6 to 1. Now the problem right now is we can't really tell which one's biggest because they're not really apples to apples, but there's a way to get these combined. I know you're already thinking. And lastly, her original height to her fourth height is 7 to 2. We know the tallest of those heights is 4 feet, and we want to find the shortest. So first off, we got to figure out which one's tallest, but it's kind of hard to tell, right? It looks like height 1, but this isn't an apples to apples comparison. So let's try and match these up. If height 2 is really 6, we can make this a 6, right? Now they're matching up. If this is 6, what does this have to be? It's gotta be, right? So now you can see more clearly that height 1 has a relationship with height 2 and height 3, a 16 to 6 to 1 relationship. So definitely height 1 is the tallest there. Now look over here. Is height 1 taller than height 4? So height 1's taller than height 2, which is taller than height 3. So height 1's got to be the biggest. And what's the real height of height 1? 4 feet, that's the biggest. So this is really 4. If that's really 4, what should this be? Yeah, 6 quarters, right? 6 quarters, or 3 halves, right? Yeah, 1.5, yeah. So if this is really 6 quarters, then what's this got to be? 1 quarter. And clearly height 3 is the smallest, and that is what we're looking for. So 1 quarter of a foot was her smallest height. Okay. Now we're working on a piggy bank problem. Oh! How I did it in the video yesterday, I figured out why it was coming out negative. It wasn't because the problem was wrong. In fact, the one that's on there on that test right now that I didn't change apparently on yours, Lexi, I don't know. But it's totally solvable.
Wait, so you did it wrong? Are you wanting me to set this up?
I did it wrong. Remember when I was like, I can't figure out why this is coming out negative. I thought I plugged in the numbers wrong. I did it wrong. There's a thing we forgot about. This is the problem with me being so tired. So, check this out. My piggy bank has only pennies and nickels in it. Let's have P and N be the number of pennies and nickels. So this is the total amount of coins I have, right? This is the total amount of coins I got.
Wait, Mr. Mark, are you wanting me
You gotta pick one or the other. And once you're back, you're back. Got it? So P plus N is the total number of coins, yeah? It says 2/5 of the coins are nickels. So 2/5 of the total amount is going to be nickels. It says if I remove 300 pennies. Well, that's the total minus 300, right? 3/7 of that, of meaning multiply, right, are pennies. But here's the catch. Here's the catch we didn't catch the other day. P is how many pennies I had originally, right? Do I still have that many pennies? I removed 300. We removed 300 from the total, and they were all pennies. So it's not equal to the pennies we had before. It's equal to the pennies we have now. And this should solve all our problems, unless this one's also goofed. All right, so here's what I'm going to do. I'm going to rearrange all these to make them a little bit nicer. I'm going to do elimination substitution. So I'm going to times everything by 5 and distribute the 2. That's going to give us 2p plus 2n equals 5n. You guys seeing that? Times everything by 5, distribute the 2. And getting my n's together, I'm going to have 2p equals 3n. So that's from this guy. From this one, I'm going to times everything by 7 and distribute the 3. So 3p plus 3n minus 900. And when I times this by 7, it's gone. When I times this by 7, I get 7p minus 2100. We're going to combine the like terms by moving that on over. So we're going to get 3n equaling 4p, and after I add 900 over, we're going to get negative 1200? No, yeah, 1200. Now check this out. We've got our two equations right here. What can we do? Elimination or substitution? What would you rather do? Why elimination? That's also true, but couldn't you just do a sub and replace 3n with 2p? That's pretty quick, right? So I'm going to do that. I'm going to do it in a different color. Do it in lilac. So instead of writing 3n, I'm going to write 2p because they are the same. Oops, negative 1200.
So you said I can't get my hands and do this?
Correct.
Give it to me as a problem?
Once, no, you cannot do that. So pennies are 600. Yeah, there was a way to do it where you get nickels before pennies and you don't have to find them, but like, it's okay. We can totally do pennies. Notice this. Double what p is equals 3 times n. So this is 1200, right? If we double it, we divide that by 3, how many nickels are we going to have? 400 nickels. Yeah, I forgot about that minus there. The p value no longer represents the amount of pennies we had before. That's what happens when you're tired. Those are the real problems. In life, word problems are the only problems. Maybe yours, maybe not theirs. Should we talk about the baseball team one? Should we do all these guys? What do you want? I'm here for you. But we might not have time to do every single one on every single test. So it's up to you. My baseball team lost 9/13 of its game this season. So 9/13 of the total amount of games. Well, isn't our total amount of games the number of wins and losses put together? We lost 15 more games than we won. So let's think about this. Is this true?
I'm just looking at which ones I need and not doing.
Did we win more or lose more? We lost how many more? So what do we need to add to make up for that? If we add 15, wait, no, we lost 15 more already, right? We have more losses than wins, yes? So adding 15 isn't going to make them equal. What do we need to add 15 to? The wins, right? Yeah, because our team sucks.
You can do the fish one, the chicken one, and the chopped one.
I am not. All right, cool. So then we're going to do elimination substitution to solve this. Let's go ahead and clean up these equations. This guy, oh, that's not an equation. The games this season, this is just stuff. 9/13 of its games this season. We lost 4. How many games did we play?
James is like, I'm looking at some.
That's a good idea. It's happening. So we know that I'm losing my brain. Well, we can do all the ones that you guys want to do. We already did some of the mediums yesterday. And we lost 15 more games than we won. How many games did we play this season? So this is true. Where's my other equation? My baseball team lost 9/13 of its games that we played this season. 9/13 of the total amount of games. It's equal to G. Anyway, we said it equal to the total amount of games, but oh, my team lost this many games. So this is equal to L. There we go. Sorry, right. The total amount of losses is 9/13 of the games. Oh, boy, that was scary. All right, so check it out. We know L is equal to this. Let's go ahead and simplify this. I'm going to distribute that 9 and times by 13 to everything. That means 9W equals 4L. And isn't L the same thing as 15W, or W plus 15? It is. So we can replace L with W plus 15, and we can solve for the wins. Or
The 2/7 equals, and the other side is just equals. Could it be total?
I gotta stop answering your questions. I gotta move on, okay? They're on the clock. All right, so if we distribute this 4, we're gonna get 60 and 4W, right? That means 5W is equal to 60, which means W is equal to 12. Now, how many losses does that mean? It says we lost 15 more games than we won. So if we won 12, we must have lost 27. That's a total amount of games, which is, to answer their question, 39 total games. Yep, and it will. As we move further on, you'll feel better because it's more recent. 6 and 7 are going to feel ancient. All right, in a far-off land, fish can be traded for 8 fish. 8 fish. So we got fish, that's 8. Can be traded for 5 loaves of bread. So it's 8 to 5 relationship. And a loaf of bread can be traded for rice. 1 loaf of bread, 3 bags of rice. The question is, how many bags of rice is 1 fish worth? So this is what we want to know, right? 1 fish, how many rice? Well, to connect these guys, connect fish to rice, we probably need this, right? If that's times 5, this is going to be 15, right? So it looks like 8 fish, 15 rice. So I'll write that down. 8 fish, 15 rice. So what will 1 fish be? It's going to be a fraction. If 8 gets you this much, we got to divide by 8, right? 15 eighths. Yeah. Kentucky, how are we feeling? Yeah, me too.
Mr. Murph, I feel like there's something missing for the fish.
There is not. You need to find how many fish they started with. After 2 days of reducing it, you're down to 2,000 or whatever it is. I don't know. All right. While eating out, Mike and Joe each tipped their server $8. Mike tipped 20% of his bill. So apparently $8 is 20% of his bill. So what was Mike's bill? $40. And Joe tipped 25%. So apparently 8 is 25% of his bill. So what was his bill? What was the difference in their bill? $8. Yeah. Kentucky, are there any problems you specifically want to do? Is your goal just to get all the basics done or what? Okay. So you're not really interested in these intermediates? Yeah, but Mars is currently not here. Right, correct. Yeah, you do that a lot. Reminder, all my 8th graders, you can just go home. Something to think about. You're never going to finish it, that's the point.
But then I'm gonna end with a D-.
You're never going to end with lower than what you have right now. Tell you that much.
What?
Hmm?
Yeah, actually, what?
She does because she didn't turn anything in for like 6
I
weeks.
just want to see it.
It sounds like me.
Yeah.
What if I always deleted it?
No. My mama got this for me.
Well, do the best you can, right?
Mama said share.
Yeah, but remember on the final I'm pretty lenient, right? So do your best. Just do your best, guys. All right, so we're doing this one, right? So after 2 days of selling stuff, they've got this much left. So check it out. Let's have this represent our original, okay? If I've gotten rid of 40% of it, how much is left? So if we take 60% of our original, that's 1 day of selling, right? And 60% again, that's 2 days of selling, right? 60% of 60%. Apparently that's going to leave you with 7,200. Simplify. This is really just 6 over 10 times 6 over 10 times F, right? We can divide by 36, right? Okay, cool. So that's going to leave us with 1 over 100 times F equals, when we divide by 36, that's going to leave us with 20. 36 times 2 is 720, so yeah. No, 36 times 2 is 72, so yeah, 200 is what we're left with. So that means F was originally 200 with 2 more zeros on the end. That's quite a bit. All right, you guys ready for 653? This one right here is so easy if you know how to do it. This is an Emma Porter favorite.
I do like 2 and
Okay. Bye-bye, Dom. Bye, Dominic. All right, check it out. We want to know the ratio of acid to water. So here's how we're going to do that. Total acid over total water. Does that make sense?
Yes.
25% of the solution, okay, is acid. And 75% of the solution is water. Okay? S represents how much of the solution we're using. Maybe it's gallons, maybe it's liters, I don't know, right? We're using some amount. Now, for the other solution that we're mixing in, it's 15% acid, but we're going to do twice as much. So 15% of the other solution is acid, but we're going to use twice as much. So if the original amount was using S gallons or something, the other solution is going to be 2S gallons, right? Does that make sense?
Yeah.
The other solution is 85% water, and again, we're using twice as much as the original. Now check this out. What common factor does the chopped share? Yeah, that's true. But, like, we'll get that in a second. They both share what? S, so we can take out an S. They all share over 100 as well. We can take that out.
Yeah.
So guess what we're left with? We're left with 25 plus 15. Now, the reason I'm showing you this is because what common factor does the bottom share? S and over 100. So we can take those out, and we're left with 75 plus 85 times 2. Oh, yeah, I forgot. Sorry, 15 times 2, right? So that's really 30. And after we take out S and 100, we're left with 2 times 85. That's going to be 170. Now, check this out. Is this timesing S over 100 times? Yeah. This is also S over 100 times. We can divide those out. It never matters what S is. It doesn't matter how many gallons or liters or whatever, right? It's all proportional. So really all we have to do for this problem is do 25 acid, 15 acid doubled, right? 75 water, 85 water doubled. This is 55 over 100 or 245. Simplify or don't, I don't care. Yeah, if you know why that works, then it's super easy to do. All right, that's it for 6. Let's go to 7. Remember when Steely almost dropped an F-bomb on the 5th graders that were laughing about that? That was crazy. That was crazy. He got so mad that they were saying 6-7. Caden said 6-7 just to see what would happen around the 5th graders, and they started like exploding 6-7 around the room. And Steely was about ready to like drop an F. Yeah, he was. He's like, shut up. And I had to be like, Steely, it's okay. They're just 5th graders.
That reminds me of when the basketball games were going.
Yeah.
Or maybe it was the football game. But I kind of like grabbed the kid by the shirt and was saying 6-7. And I just threw shut up in his face. I don't remember who it was.
Don't do that. Sometimes violence is the answer, but you're not. Yeah, don't do that. Don't do that. I don't think that was worthy. This is true.
Well, Your Honor, you weren't there. You can't say anything.
Low key, you kind of had to be there, right? All right. Let's talk about this one. So this is about proportions. So we're gonna have like indirectly proportional, directly proportional, all that jazz, right? So just quick refresher. Indirectly proportional means as one goes up, the other goes down, and vice versa. That kind of relationship is this kind of relationship. Okay? A timesing relationship. Think about it. If I have 5 and 10, what do they multiply to? Now, in order to keep that 50, if I change that 5 to like, I don't know, how about 25, what will I have to do to the y value? I'll have to bring it down. Do you see how that's inversely proportional? Oh, I wrote indirectly. I should write inversely. I always write indirectly.
It's the same thing.
It's kind of the same thing.
Close enough.
Inversely is accurate. All right, now let's talk about directly proportional. That means both go up or both go down, right? And it's dividing, and it has to be, if you think about it, right? If I have two numbers, like 50 over 2, that equals 25, right?
Yeah.
If I turn that 50 into 100, in order to keep it 25, what's going to happen to the 2? Hundred divided by what is 25? What? 4. Yeah, I know. We had a brain fart there. So notice that not only did the 50 go up, but so did the 2, right? So that's definitely a directly proportional relationship. Okay, cool. Chocolate chip cookies. We got 20 cookies. Earlier, Christina was trying to say Chromebook, and it sounded like grumbles. And I was like, what kind of cookie is a grumble?
What's negative? Oh, no, it's a crumble.
Negative 6. Ooh, yeah. Negative 600 over 9 is negative 200 over 3. Some of the answers are going to be fractions. Are you sure it's negative?
Well, I had minus 900. Minus 310 is multiplied by 2 is minus 900. Plus 600 negative 300 is multiplied by 2 is really a fraction.
Yeah.
Negative
Okay. Could be. But you're getting a negative answer overall? Negative 600 pennies?
Oh, no.
All right, cool. You think about it. All right, 20 cookies calls for 2 3/4 cups of flour. This is definitely a directly proportional relationship, right? More cookies needs more flour, so we got to use division. They want to know if we're making 10 dozen cookies. How many cookies is 10 dozen? 120 cookies. All right, well, if we're not changing the problem, clearly we times by 6 over 6 to get there, right? Right? Yeah. So it's definitely 6 over 6 to get there, which means to get the flour for that many cookies, we need to also times by 6. So that's going to be 12 and 18 quarters. Now, let's simplify that just because it annoys me. 12 and 18 quarters is really 12 plus 4 1/2, right? So 16 and a half cups. Yay for directly proportional. All right.
Is that all this is after this?
Seven's actually kind of easy. Like, I'm gonna be real with you. All right, 8 people are mowing a lawn in 5 hours. If I increase the number of people, will the time it takes to mow the lawn go up or down?
Down.
It'll go down. So more people, less time. That must be inversely. So it's a times relationship. So we know the people and the time have a relationship like this. PT. We know when P is 8, T is 5, right? The question is, how many people do we need when T has to be 4? We want to decrease the time. Well, this is really 40, right? So what's P got to be? Yeah, we need 10 people. Same amount of work is done, right? We're doing the same lawn, or number of lawns.
I think I always used to like complicate this and do like,
That is correct. I was there. I remember.
yeah.
After doing
You could study and practice.
homework, I might even
Did you know
easy
that doing homework,
makes you smart.
it makes you smart? You make mistakes and you learn. If you do the homework, it's so much easier.
When I started doing the
And it counts as half the credit you need, right? Do the homework.
when I started doing the homework, one half of the paper was just
Yeah, and sometimes that happens. It's called learning, right? Notice I don't sign 100 million problems. I sign like 6, right? There's a reason for that. You really only need 6 if you do it right. And you don't even need to do all 6, right? You can just do the basics or something. Learning is important, and it takes you doing it, right? That's what's so important about this. A swordfish drives a car at 50 miles per hour for 4 hours, then at 60 miles per hour for 2 hours. We want to know their average speed. Fam?
55.
No, it doesn't work like that.
Oh, yeah.
Wait, yeah,
Average speed is total distance, total time, yeah. That makes sense, right? So, for the first leg of the trip, he's driving 50 miles per hour for 4 hours. How much distance is 50 miles per hour over 4 hours? 200 miles. But that's not the entire trip. He's also driving 60 miles per hour for 2 hours. How many more miles is that?
120.
How much total time was he driving?
320.
4 hours and
2 hours.
2 hours. You guys are answering a different question. Most wrong answers, and this is something you should remember when you're in class with other people. Most wrong answers are somebody answering correctly a different question, right? So you're right. This is 320 total miles over 6 hours. So we divide this. It's not going to divide out nicely, but we are going to get 160 over 3. So that means it's about like 53 and a third is the average speed. Now, I do not want you to simplify that. Okay? Just do this.
That was close.
Yeah, it's somewhere between 50 and 60. It's not going to be more than 60. How can you average more than 60 if you never drive more than 60?
I wasn't looking at the time.
How can you average less than 50 if you never drive less than 50? It has to be between 50 and 60, right? But it's not right in the middle because we didn't drive 1 hour each, right? Chloe can dig a ditch in 9 hours. So I have a question for you. If she can dig an entire ditch in 9 hours, how much of a ditch can she dig in 1 hour?
1 night.
A ninth of the ditch. So a ninth of the ditch times h is how much Chloe digs per hour, right? If h is 0, she hasn't dug anything. If h is 1, she's dug a ninth. If h is 2, she's dug 2 ninths. If h is 9, she's dug 9 ninths, which is an entire ditch. Now, Ember is helping her, although helping her is not really accurate because notice that if she joins in, it still takes 8 hours. So we had 2 people doing it, and it's almost exactly the same as if one person's doing it. So I don't know how fast Ember is digging, but whatever her speed is, let's call it I. And she's digging for the same amount of time as Chloe, right? They're both going to dig the entire time it takes to get the job done. Now, this should equal the amount of ditch she digs and the amount of ditch she digs. How much total ditch will they dig? 1 total ditch. That's our goal, right? We want to know when this will equal 1 total ditch. Now, they're saying that the 2 of them together, how long does it take? 8 hours. So we actually know what h is, right? It's 8 for both of them. So that means Chloe is going to dig 8/9 of a ditch, and Ember is going to dig 1/9. So we know that this right here is equal to 1/9, isn't it? This right here has to be 1/9. Wouldn't you agree? 8/9 plus 1/9 is 1. So this has to be 1/9. Write that down. What do you times by 8 to get 1/9? 1/72. If you divide by 8 to both sides, right? Ember is digging 1/72 of a ditch every hour. Ember is barely working. There you go. So here's something I always forget to do, and I forgot this yesterday. We have to answer the question. How long does it take Ember to dig the ditch herself? How many hours will it take Ember to dig one ditch herself? 72 hours, right? 1 hour, she's only digging 1/72.
So that's like 3 days.
It will take Ember 3 days to do what takes Chloe 9 hours. This is true. It is exactly 3 days. I have a sense of humor. All right, let's move on. Hey, well, look, we're on the intermediates. There's only 4 of them. Should we do all 4, or should we skip around? What do you want to do? I'm going to be real with you. I don't like the Eli problem. It's not going to be on there. It's not going to be on there. What's up? Okay, good job, kid. Why worry? Be happy. Yesterday you were Santa Claus. You can be anything you want, even Santa Claus.
What's that one line?
You can be okay.
Saturday, 10 a.m., Santa's coming to town.
Yes, it's coming to town.
You won't. So, Christina, when you do this and you turn in the quizzes that I've sent out, you are not going to have an F. You've just turned nothing in. That's why you have F. But if you turn stuff in, you're going to have like a B easily. Maybe even A. Yes, we can do that. Okay? You know most of your stuff. Some stuff, not as much as you should. Yes. And I got you. You'll be okay. I got you. Okay? But I think it's going to be enough. I'm on record. Mic's on. B, easy. B, easy. Maybe B plus A. Maybe. But B easy. Easy. You kidding me?
Will I get a B?
You do if you do the intermediates. Easy. Easy B if you do any of the intermediates. Yeah.
How am I supposed to do it if I don't have X?
This one?
Yeah, so, no, this one. Because I have this and then I have that. But then I know that.
So you should be able to use Z to figure out Y, right? And once you have Y, you can use that to figure out X.
But this doesn't equal this, does it? Because this are completely
This equals this. So if Z is 5, Y will have to be 1.
Oh, I didn't think that this and this were.
They have to be, yep. Same X, same Y.
Maybe if I get a B, my mom will finally love me.
No, she will not. All right, so your mom already loves you. She loves you so much.
I know.
You're kind of her favorite boy, right? All right.
Our only.
Yeah, well, it's a tough competition, but I think you might win. What?
731 is the one that always confuses me. 723.
Okay. We can skip 723 because I know Kentucky's like, I don't care what intermediates we do. 731. Guys, we need to think about relationships. Okay? If I increase the number of chickens, what will happen to the bags of food? What do I need to do?
They will go
away faster.
They're going to go away faster, but that's about time. What I'm talking about is what do I need to do? If I have more chickens, I need more food, yes? So we know that's directly proportional, and that is a relationship like this, yes?
Yeah, I remember doing this one.
Now, we also know that if I increase the number of bags, the time will go up before they starve, right? So more bags means more time. So that means B is also directly proportional with the days, right? Now, I can only write this if it is also true that C and D are inversely proportional. More chickens means fewer days. Yeah, right, yeah. So this is exactly what we want. So we know that 20 chickens eats 8 bags in 5 days. Oops, sorry, 8 goes down here. My bad, 8 goes down here. Days is 5. We want to know how long So that's days, right? How long does it take 9 chickens to eat 30 bags of scratch? Let's simplify and solve. 100 over 8 equals, this is 3 over 10, right? Okay, let's times by 10. Let's just simplify. So this is gonna be like what? 25 over 2. Times by 10, divide by 3. So that means we get 250 over 6 equals D. After timesing by 10 to everything and dividing by 3. So this many days. You could simplify to 125 over 3, but I don't care.
Like I write 9 backwards. I don't know why.
You should get some sleep. All right. What about this one? Bart's writing on a chalkboard. Yes or no?
Yeah.
Bart Simpson.
That's the one. All right. So here's the deal. You know how Ember and Chloe were technically working together? Well, Bart and Nelson are working against each other. Bart can write an entire chalkboard in 20 minutes. So how much of a chalkboard does he cover in 1 minute? 1/20th for every minute, right? Now, we're not going to add on Nelson because Nelson is erasing. We're subtracting. How much of a board can he erase in 1 minute? 1/30th every minute. We cooking? Now, what we want to know is when will Bart win? When will he fill up an entire board? So when will it equal 1, right? They're going to keep pulling away on each other, but eventually Bart's going to get to a full board, and I guess at that point it doesn't matter if Nelson keeps erasing, right? So this is what we got. How can we make this easier to work with? How?
Like,
Well, how can we get rid of fractions? How can we get rid of fractions? Yeah, what should we multiply by that's going to get rid of divide by 20 and divide by 30? Timesing by 60 is going to get rid of both of those, right? So what we're going to end up with is we're going to end up with 3m minus 2m equals 60. Hey, guess what? M equals 60. It'll take him 60 minutes. Wowee! So, Kentucky, you should target the ones that you know you can do based on what we're learning today, and then you should study those. That way you're good to go. Guess what we're doing next week during class? We're reviewing for the final. So you're going to have plenty of opportunities with more of these to try them on your own, okay? Yes, it was. Hey, guess what? We're done with 7. Not for you. Wait, tomorrow? Okay. All right, so let's go to 8. Your mom is going to kill me because you are still here. You need to go home. She probably hates me. What?
If we're multiplying these by 2, wouldn't that make this side 2, but you can't do
0 times 2 is what? 0 times 2. Wait till the camera and the mic is off. What? Should we do 812, yes or no?
I feel like that's easy.
Okay. If you don't make small mistakes, then easy.
Yeah.
All right, 813, find the distance between the points, yes or no? This is Christina's favorite problem.
These are easy for me.
Kentucky, you want to see them? It's okay if you do, because we're doing this not just for you, but everybody watching at home. Hello, viewers. Because I'm going to tell you right now, if you want it at all, there are probably 100 people that also want it. Because I imagine a lot of people want to see every single one of them. So we don't have time for that. But if you want it all, you should just say yes.
I mean, I have notes for this already.
Do you know how to do it?
Yeah. Isn't it?
I'm going to do it real quick. You're taking forever. That's 10 distance. I don't care about plus or minus because we're just going to square it anyway for Pythagorean theorem. And that's 2. And we're doing Pythagorean theorem. So I don't really care whether it was plus or minus. It's not slope, right? So we're going to get 104 rooted. That's the distance. Find the slope. This does care about direction. So here is delta y. That's definitely plus 1 for delta y. This is delta x. That's definitely minus 16 for delta x. Delta y over delta x because rise over run. Our slope is 1 over 16 with the negative sign anywhere. I don't care. You can even circle this. I don't care. All right. Should I graph this? Find numbers that work. Yes or no, Kentucky?
8 and
Negative 6 and 0 works, doesn't it?
Yeah.
This becomes negative 18. This becomes negative 18, and this becomes 0. So yeah, that works. What's another pair of numbers that work, Kentucky? No, don't do that. Let him think. Do you know why it's 0 and 9?
Yeah, because 9 times the negative, 2 negative would be negative 18.
And then this should be 0, not, yeah.
See, I'm smart. I don't need,
You are.
I don't need Marshall's charity.
So any points we could have found, Kentucky, any points that you could have found would be on this line.
Well, I don't like thinking too.
That's not true. You actually do like thinking. You're a good thinker.
Well, my
You
brain hurts.
overthink. That's why your brain.
No, Kentucky is afraid that if he thinks, he will be wrong, and so he tries not to think. But here's the thing. He's actually a good thinker, which is why he does pretty good in this class when he actually does the homework. All right. Graph the line that has this slope. Okay, negative 4, comma 3 is definitely on our line, so we should definitely put that down. And then if our slope is negative 1 over 9, that means if we apply our slope, we're going to find another point, right? So this means we have a rise of negative 1 and a run of 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's going to get us another point. All of our points will be separated by a slope of negative 1 over 9. That's a beautiful line. Just apply your slope. Do we need to go over how to find midpoint, Kentucky?
Mr. Nexus, 10.2.4 is time to do it in class we did it wrong. I don't know if I'm gonna do it right.
10 to 4?
It's like the sum of the roots of blah blah blah, sine, cosine, and b. 10 to 4? Down 7 to be down.
Negative b over a and c over a. Right? I don't know. I'm not too worried about that because you guys missed out because we had assembly. Surprise assembly. All right. Kentucky, should we find the midpoint?
I guess.
Okay, cool. The midpoint is the average location. So we're going to average our x's, means add them up and divide it by 2. So if I do that, I get 3 halves. 1 1/2, which is 3 halves, is in the middle of 9 and negative 6. Kentucky, what's our average y? Yeah, 10 divided by 2 is 5. Ta-da, you found the middle. All right, finding standard form. Christina's favorite form. No, she learned standard form Ukraine style.
Yeah.
I'm sorry.
What's your change shop?
My favorite formula in school.
Yeah, it's the same way I learned it in school. It's like you have to write down everything, use all the formulas, no thinking, just write stuff.
No,
Yeah. Yeah, and it works if you don't make any mistakes. Because if you make a single mistake, which is very common because there's lots of negatives, and since you're not used to thinking, you'll never catch it, right? You'll just be like, I hope. Yeah.
I'm just like, oh my gosh, Jesus.
I know.
take me.
So standard form is this guy, right? And it's important to know that a over b is negative a over b equals your slope. So it's a over b is your slope, but you change one of the signs, right? We've talked about this. So delta y is going to be minus 11 here. And delta x looks like it is minus 7. So our slope is really 11 over 7, right? The negatives divide out. So slope is 11 over 7.
Wouldn't it be positive 11 since it's only 2?
You got it. I knew that felt weird. Nice job. Good job, Kentucky. So this is really our slope, right? The minus sign has to go with one of them. It doesn't matter which, right? So plus 11, negative 7, doesn't matter where the minus sign goes. But that means A and B, we're going to change one of the signs, and we're not allowed to have A be negative. So A has to be greater than 0. And A, B, and C have to be integers, right? Meaning they can't be fractions. So we're not allowed to have fractions. That's what this means. Have to be integers, no fractions. And A has to be positive. So we're not going to write negative 11 for A, right? We have to change one of the signs, so let's change this one. This is this slope, right? One of the signs got changed. Now to figure out what goes here, we just have to plug in a point. So let's plug in negative 4 and 2. I'm going to get negative 44 when I plug in negative 4 here. Plus 14, that's negative 30. And if one way to check to see if you goofed is to plug in the other point. If I have 2 points, how many different lines will go through them? One line goes through both of them. You can see it, can't you? All right. So if you plug in both your points and they work, then you must have the right equation. That's the only way it could work. If they don't, then you have the wrong equation. So let's plug in 3 and negative 9. 33 minus 63. Yeah, it's negative 30. Here is our equation. This is it. This is goodbye forever. I knew you would.
You know, let's just do all the basic
I
ones.
did all of it up to this because it's 10.4, 10.5.
That's fine.
And then this is, I need extra space, I think. And then I didn't end up using this.
Okay. Lexi,
Yeah.
I'm proud of you. Very proud of you. Well, never mind.
You ruined it.
Lexi, this is goodbye forever. Bye.
Wait,
I'll miss you.
leaving?
No, can you get to bother him when he becomes a freshman?
All right.
Wait, you're leaving now?
I don't know. All right. Let's do this. Find the slope.
Wait, it's 3.
This is y equals mx plus b. So m is negative 3.
Yeah, no. So smart.
X-intercepts, what do they all have in common?
Uh,
They're all...
0 and the X. Y.
Yeah, think about it. This could be an x-intercept, right? Right here? Nope, stop. See how this is an x-intercept right here, this dot?
Yeah.
That's 4, 0. So which one was 0, the x or the y? The y.
Y.
Now, a y-intercept could be somewhere up here, right?
Yeah.
That's 0, comma 6. So which one was 0?
X.
Thank you. So let's find this. Let's find the y-intercept first. If x has to be 0, what are we going to get for y?
It's gonna be negative 4.
If x is 0, what does this become?
Oh, wait, no. That's just 0.
0 minus 1 is negative 1.
Negative, yeah, I was thinking like. I'm stupid for this.
It's a
If y is 0,
And that would have to be 1 over 3. Yeah, right?
what do you add? What do you take away 1 from to get 0? What minus 1 is 0?
Wait, 1.
So how do I make this 1 negative 1/3? Because the negative 3's will divide out, and I get 1 minus 1.
That's what I was thinking. I just.
you were wording it very
Stupid.
Hey, relax. So then we draw our line, and we've got our graph. This next one wants to find the slope-intercept form. What is slope-intercept form?
That is. Y equals. Yeah, y
What's the slope of the y-intercept? Well, they give us the slope of 4. And they tell us that one of the points on the line is negative 3, 0. So negative 3, 0 should work. So that means this has to be true. What will b have to be?
plus LL.
Yep, so make sure you write the final equation.
Awesome.
That's it. Okay, intermediate time. Should we do 814, find the distance between these and the origin? Okay, cool. We're going to find the distance between 0, 0, which is the origin, and 10, negative 9. Guys, it's just like that first one we did. How far is 0 from negative 9? How far is 0 from 10?
10.
Then we do Pythagorean theorem.
We do?
That's distance, isn't it?
Yeah.
Distance formula is Pythagorean theorem. 181, rooted. Okay, cool. What about this one? How far is 10 away from 0? Negative 10 away from 0.
Oh, yeah, negative 10.
It's 10 away, because we're going to... Negative 10 or 10 doesn't matter, we're going to square it. 0 going to 9 is 9. Hey, it's going to be the same distance, isn't it? root of 181. You might notice that you always get just whatever these numbers are, right? We're going from 0. How far is 11 away? 11. How far is negative 7 away? 7. So it's going to be 121 plus 49. 121, and this will be 49. We add them together. We're going to get 170, root of 170. So far 181 is tied for a win. What about this? Well, it's going to be 12 and 5 away, which means 144 and 25. That's 169. Nice. And lastly, 169 and 9, which gets us 178. So which were the furthest? These two, they were a tie. That's so silly. Turning the page. Do we need to go over these?
I don't know, I never looked at the
It says graph y equals negative 5. That means I want all the points where y is negative 5. Kentucky, can you give me a point where y is negative 5?
negative 5.
That's not a point. I need two numbers.
Wait, no.
0, negative 5. You're right.
Yeah.
1, 2, 3. So that's here. Give me another point that has negative 5 for y.
Positive 0, 5. Wait, no.
Y has to be negative 5.
Negative 5. 1 negative 5.
Yeah, 1 negative 5 works. Give me another one.
2 negative.
What is this going to look like? Don't say a line. It's a horizontal line. Now, what is the slope? Well, if you look, delta y between these 2 points, like for instance, did we go up at all?
No.
So delta y is 0. What's delta x between these 2 points?
Instant.
What's the change between here and here? Going from here to here. 2. 0 divided by 2 is 0. Our slope is 0. And that makes sense. It has no steepness, so it has no slope. Yes. Let's graph x equals negative 8.1. Kentucky,
Yeah.
give me a coordinate where x is negative 8.1.
Negative 8.10.
Yep, so that's here. Give me another coordinate where x is negative 8.1.
Negative 8.11.
Negative 8.12, negative 8.13, all of these, right? No, yeah, all those are right. So this is going to be what kind of line?
Whatever diagonal line.
Well, that'd be vertical.
No, wait.
It's okay.
Diagonal is this way.
That's okay.
I never.
Kentucky, what's delta y between these 2 points?
Nothing. Undiagonal.
Delta y is how we're changing up. Pause, you're not answering my question. Between here and here, how much did we change going up or down? 4, so delta y is 4. What is delta x between here and here? Stop, Mars. No, delta x has to do with how much we go right or left. How much do we go right or left?
0.1.
How much do we go right or left between these 2 points? Did we go right or left at all?
Oh, no.
So it's 0. Are we allowed to divide by 0?
No.
So this means undefined. Undefined. It has no definition. If you were to call this any number, you would break the rest of math. So it must remain not a number. But it makes sense in this context, right? We have a lot of steepness, so it's going to be delta y of anything and not moving over any at all. That's it. I don't want to do this one. It's a lot of words. I don't want to do it.
Okay.
It's estimating slope. You can estimate slope. I believe in you. 831. I don't want to do it. It's really annoying.
Okay.
Mars, did you do 831?
I hated it.
I hate
It was
831.
If we just do a few intermediates at that point,
I don't want to know it, or don't want to do it.
if we just do a few intermediates at that point.
Yeah, that's fine. I'm gonna basically let Mars choose because you're kind of ambivalent. Mars, do you want to see 8-3?
What's ambivalent mean?
Ambivalent means you don't really care.
Oh, okay.
833. Mars, do you want to do 833? Make this the middle.
It's worse than a way.
All right, so here's the idea. If P is negative 1, 4, and Q is 8, negative 5, I want to create a point called T that makes Q the middle. Well, if Q's the middle, these are 9 apart, right? How far should these be apart? also 9 apart, so we need this to be 17. If these are 9 apart, going down, how far should these be apart? Going down. Now it's the middle. You can check it. Negative 1 and 17 adds to 16. Cut in half, you get 8. 4 and negative 14 adds to negative 10. Cut in half, you get negative 5. It is indeed the middle. Find the equation in standard form. That's this guy. Remember, A and B and C have to be integers, so no slopes. And A has to be greater than 0. It can't be negative. Okay? So let's go ahead and take our slope, which is negative 3 over 5. That means our A is 3 and our B is 5, right? We got to change one of the signs. And we definitely don't want A to be negative, so we should probably change the negative 3 to be a positive 3. You got to change one of them. Could have done a double negative, negative 3 and negative 5, but that would have left us negative, and that's not allowed. All right, and then we're going to plug in a point to see what goes on the other side for C. Looks like we get 9 minus 15. Well, that's negative 6. Do I have any fractions? No, so they're all integers. Is A negative?
No.
So this is standard form.
Wow.
Intermediate does not mean hard. Intermediate means you have to have a basic understanding mastered, and then you can do them. The hardest ones are the basics because you're going from nothing to understanding a concept. Whereas basic is just taking it a little bit further, right? Going from basic to intermediate. So this next one, prove that this is the slope. So basically what we're going to do is we're going to rearrange this to look like that. Because if we rearrange this to look like this, the number next to x will be the slope. And guess what's going to be there? That. So here we go. ax plus by equals c. To make it look like this, don't we need to get y on its own?
Yeah.
So I'm going to subtract ax. I'm going to write it out front because that's where the x is on the other one, right? It's out front. Subtract ax. And then what do I need to do to get y on its own? Divide by b to every term, right? So you get this. And if you look, this is clearly our lowercase b. And this is clearly our slope. Proof. All right. Next, we want to make a perpendicular line. What does it mean to be perpendicular?
We need to go through another line at a 45 degree.
Perpendicular is not 90 degree. Perpendicular is a 90-degree angle. So basically what it's going to do is it's going to take your slope from here and it's going to rotate that slope the exact opposite direction, right? That's what's going to happen here. Parallel. So here's the original line. You can see its slope is 3 over 4, right? So we want our line to be the exact opposite slope. We're going to do 4 and 3. And we are going to change one of the signs. That way it's heading in an opposite direction. So it's the exact same thing as this. We're just going to change one of the signs again. That's going to create a perpendicular intersection. Now, it's not going to equal negative 8 because otherwise we're not going to answer this other thing. They said it has to have the same x-intercept as the original line. So let's find the x-intercept of the original. X-intercept will have what in common?
They don't have any 4 or y.
So if y is 0, what times negative 3 gets you negative 8?
Negative 8 over 3.
We've already got our negative. We don't want to get rid of it. So 8 thirds. 3's divide out. The negative stays. We get negative 8. So apparently this should also have 8 thirds 0. So they share the same point. Okay, cool. So Kentucky, what is 4 times 8 over 3? Over 3.
Yeah.
Now, is this standard form?
Yeah.
It's not. Why isn't it?
No, it's not. I don't know.
Everybody makes this mistake.
Oh, fraction.
Can't have fractions.
Oh, yeah.
A has to be positive, and we can't have fractions. So if we times everything by 3, then we get the standard form, which is this. You have to do that. All right, now we want to find a line that's parallel. What does parallel mean? Yeah, means they never intersect, which means what will be true about their slopes?
They have the same slopes.
They got to go at the same angle.
Same.
If they don't, they'll intersect. So it's got to be the same slope. So let's rearrange this equation. See, if I rearrange that, I can clearly see the standard form of this would be this, right?
Yeah.
Yeah? Okay, so that means the line we're looking for is parallel. It has the same slope, right? It's got the same slope, but it doesn't have -3 there because otherwise it'd be the exact same line. It says it has to go through this. So plug that in and see what happens. -2 plus 42, 40. Turning the page. Hey, look, we're done with 8. Go home.
I did 9 in one test, have it be known.
Okay.
All right, so now we're on the 9. Tell me if you want to skip any of these.
If Mark needs help on them, do them out.
Okay. Well, if you, how about we just say this? If you want it, say yes. So 911. No, that's not how we're playing this. If you want it, say yes. 911. 921. 922. Which is bigger, a half or a ninth? Smaller number on the bottom, bigger number overall. Let's compare these denominators. Notice that this has 2 through 98, right? This has 4 through 98 and some more numbers. So this much is the same. Sorry, I shouldn't have included the 2. Do you see how this much is the same? So these are the same numbers, except this one gets +2, and this one gets plus 202. So which number is going to end up being bigger? This bottom number is going to end up being bigger, which means this number is bigger overall, because we want a smaller number on the bottom, right?
What I like doing is just looking at the last 2 numbers and seeing.
You have to be careful, because sometimes I do like every other number. So I do like 4 plus 8 plus 16, and this one has 2, 4, 6, 8.
Yeah, I look at that for.
Well, whatever you got to do, just make sure you're looking at it. All right, this, it says graph the inequality on the number line and write the solution using interval notation. Oh, I haven't been making you guys use the number lines on these. I should be doing that. I didn't read the directions. All right, let's get x on its own. Are we going to add 5 to everything? No, we can, but we don't want to because 5 is not bothering x. What do we need to do to get rid of stuff in front of x? -1 to everything because this is a compound inequality. And divide by 3. When we divide by 3, do we need to flip the signs? No, because we divided by +3. So that means on a number line, that's this, -2 going to 2. Why are the circles colored in?
Circles are colored in because it can be equal.
Yep, it could be equal to them. And it's also in between them, right? So there you go. Using interval notation, we're going to write that x exists between -2 and 2. Now, why are we using these types of brackets?
Because those types of brackets means that they can include the numbers.
Exactly. No, it's okay. All right, we've got one more page of milds, okay, or basics on 9. So, do we need to do the January population growth? Yes? All right, originally we're at 9,444, and we're adding in 162 every month, and we want to know when is it going to be greater than 13,000? Well, it'd probably be easier if we got all our like terms together. So let's subtract 9,444 from 13,000. Here's how you do it. What's 13,000 minus 9,000? Then we take away 400, we're at 3,000. Take away 400 from 4,000, we're at 3,600. Then 3,600 minus 40 leaves us at 3,560. Then we take away 4, 3,556. Now let's estimate. 162 times 10, right? So at m equals 10, aren't we going to get 1620? Can we go up to double that? We definitely can, right? At m equals 20, we're going to get 3240. That's pretty darn close, isn't it? Can we add on one more group of 162? We'll end up getting 402. Yep, 3,402. Yeah. Yeah, just barely, because 564 is what we're going to get, right? So we need 22 months. 22 months. Now that's almost 2 years. We're starting in January. So almost 2 years. 2 months shy of 2 years means that we are at the beginning of, oh, this is end of January. So it should be,
October.
I think it's November, isn't it? If it's the end of January?
Yeah.
No.
Yeah.
12 months from the end of January gets you back to the end of January. Then 10 more months would get you October, yeah. Graph the inequality. So guys, this is what this is saying. It's saying I want where it equals 6 and where it's greater than 6. Let's just focus on where it's equal to 6 first. Kentucky, can you give me pairs of numbers that make this equal to 6?
Wait. Negative 2y and 2x. Right?
Mm-hmm.
Sound right?
Yeah.
Yeah.
2 plus 4. Yep. Give me another one. Pair of numbers that get you 6. Yep.
Y.
No. X first.
Oh. Well,
Do X first.
negative 3 and 0x.
Yeah, you're right. Why are you finding the craziest points? What about 6 and 0? That's fine. It works. 1, 2, 3. That totally works. So here's the line where it's equal to, okay? But do they just want where it's equal to? No. So that would be if it was an equal sign only, right? Let's take care of the greater than part. So here's what you do. You pick a point that's not on your line. Like, in this case, 0, 0 is a great point. It's easy to plug in. If I plug in 0, 0, no, so that means this isn't the side we want. It's this side. So this is where it's equal, and then the orange is where it's greater than. All right, speaking of orange, we're on to the intermediate side. Are you guys ready for these? We know x and y are less than 0. What does that mean?
That means they are negative.
Good. So starting from here, the thing we're given, we're going to make it look like this. Notice that x and y are in the bottom, right? So we should probably divide by x and y. Let's divide by y first. When we do so, we get this, right? Now, when I divide by y, I've divided by a negative, so what does that mean?
That is positive.
No. Well, yeah, this would be a positive. That's true, that's true, that's true.
This is true.
But what happens when you divide by a negative?
You
You have to flip the sign.
oh yeah. So it's greater.
So we got y on the bottom. Now we need to get x on the bottom. So we're going to divide by x. Conveniently, dividing by x also gets us this, right? It flips the sign and gives us this. So do you see how dividing by x gets you 1, dividing by x gets you 1 over x? And of course, dividing by a negative changes the sign back. And I always think that I goofed here, because I'm like, oh no, the signs are going the wrong way. But it's not. 1 over x, we said, was greater than 1 over y. And that's exactly what we wanted. I don't know. I used to make Twitch money, but I don't anymore. I don't stream. All right, do we need to cover 921?
Yes.
I think we do, Mars. All right, so this is 5 times 2 to the 1/3 power, all to the half power. Isn't that what that means, this guy right here? This is 2 times 6 to the half power, all to the 1/3 power. If we simplify, we're going to get 5 to the half power times 2 to the 1/6 power. And this is going to be 2 to the 1/3 power times 6 to the 1/6 power. Basically, we need to think, what power can we take this to both of them? That's going to get rid of all of these fractions. What power can we take it to? If we take it to the 6, it won't change which one's biggest or smallest, because we're doing it to both of them, right? And what we'll end up with is 5 cubed times 2 to the first. And we'll end up with 2 squared times 6 to the first. That's 24. And this is 125 times 2, so 250. So clearly, this was bigger the entire time. Okay? Yeah, 1/3. So this will be 1/6, yes? Or are you saying like 5 to the 1/3 squared? Because that will be 5 to the 2/3. Yes, that's clever. That's clever. Did you think of that, or Ukraine? Yeah? Very clever, very clever. It's the TARDIS.
I'm working on it.
Yeah. All right, which one's bigger, 2 to the 50th or 3 to the 30th? Well, if we write them out as 2 to the 5th to the 10th and 3 to the 3rd to the 10th, we can easily compare them, right? They're both being taken to the 10th now, right? So we can kind of ignore that. All we need to know is which one started bigger, right? If 2 to the 5th was bigger originally, well, taking them both to the 10th, it's still going to be bigger, right? What is 2 to the 5th? 2, 4, 8. Nope. 2, 4. We're doubling, timesing by 2 repeatedly. 2, 4, 8, 16, 32. So this is 32 to the 10th. What is 3 cubed? Which is bigger? Clearly 32 to the 10th, which means 2 to the 5th is 2 to the 50th is bigger. All right, this is a compound inequality. We're going to split it up. We're going to split it up as 2 less than or equal to 2x plus y. And we're going to split it up into 2x plus y is less than or equal to 8. We know how to graph both these individually. We just did that on the other page, right? So Kentucky, let's find points for this one where it's equal to 2, right? And then we'll shade later. Because you're going to do this one and Mars is going to do the orange one. Why does he write it or say it in that order?
I don't know.
So that.
So weird.
All right, give me another one. It's crazy. Instead of doing 0, 2. Yeah. No, it's cool, man. It's cool. Like, good job. 1, 2, 3. No, it's good, but that's the thing. You are able to think. You're not just doing it the way I do it. You're actually using your brain. That's super great as a teacher to hear. All right. Now, no, that's not what I said. All right, Mars, find me 2 pairs of numbers that make this equal 8.
0, 8, 4, 0.
Those are going to be the y-intercepts and x-intercepts. And 4, 0. 1, 2, 3, 4. Fun fact, these have the same slope. They're parallel, right?
Yeah.
Now let's think about shading. Let's think about blue. Let's try out 0, 0, right?
Yeah.
That's not on the line. So Kentucky, blue is you. Let's try out 0, 0, okay? 0, 0 is not on the line. If I plug in 0, 0 here, is 0 greater than 2?
No.
So that means the blue is everything over here. The orange line does not stop it, okay? Now Mars, let's try a point that's not on the orange line. How about 0, 0? It's not on the orange, right?
It works.
It works. Thank you, Mars. So that's everything on this side of the orange line gets colored in. What we want to know is where do they both agree? The middle, in between them. Yep. All right. We've got 2 more, and then we're done with 9. And it's almost 5 o'clock, so we're actually ahead of the game.
Oh my god, we're so smart.
Mitch has a pool with 10,000 gallons of water. 80% is full. How many gallons is that?
That is 8,000.
8,000 gallons, and we're losing 120 gallons every hour and gaining 225 gallons every hour from the hose. They do not have Flex Seal. We want to know when will it be overflowing. So how many gallons will be overflowing? When it's greater than?
That's greater than 10,000.
Exactly. Let's simplify. This is clearly the same thing as just plus 105 gallons an hour, right? And this is clearly just greater than 2,000. So as soon as we've gained over 2,000 gallons, it will overflow, yeah?
So times 20 would be too much.
20 is going to be too much. What about 19? Well, 20 gets us 2,100. So if we times by 19, it's going to get us 105 less.
Yeah, that'll work. No, wait, no, we need 20.
Yeah, it'll be underneath. So 20 is exactly what we need at hour 20. So just after 19 hours, it'll fill up, right? Because that'll get you 1,995, right? 105 less than this. So 20 is going to get you this, which is overflowing. All right, now the one that everybody hates, okay? Here's the idea. We want to find the min and max of this thing right here. Okay?
But what if we don't?
We want to make 4x plus y as big as possible and as small as possible. That's what this means.
Yeah.
To do so, we have some restrictions. Y has to be between negative 2 and 2. Y has to be less than or equal to negative 3x plus 5. And y has to be less than or equal to 3x plus 5. So here's the idea. If we graph all of those things, okay? Here's a little coordinate plane. Y has to be between negative 2 and 2. That's going to be like here. Here's 2, here's negative 2. Okay? That's what this is. You feeling me?
Yeah.
Has to be between 2 and negative 2. This is some negative slope line. So that's going to be like this. And it's going to be like this side of it maybe. Okay? That's what this is. This guy is the exact same thing, except it's positive slope. So basically, what's going to happen is this entire area is going to be shaded. But what we are interested in are the points of intersection. Because that's where the max or minimum is going to happen. So what we want to find is the point of intersection. Now, we know from chapter 8, we would find points of intersection by just like using substitution or elimination, right? To find where the lines intersect, we don't care about the shading. So instead of thinking of this as an inequality, I'm going to think of it as an equality. What happens when y is these things, right? That'll be on the line. So what I do is I make a little chart. When y is negative 2, what will happen to this guy? If y is negative 2, we need this to be minus 7, right?
Yes.
So 7/3, do you follow me?
I mean, I'm following.
We are done?
I will come tomorrow.
Yes. 10 o'clock. Okay, bye-bye. Go get sleep. Sleep. Snapchat Lexi.
Wait, 10 o'clock? For what?
She wants to continue her final because she's crazy.
If I get all the basics done, I'm happy.
I need to get an A.
Like, I start many like that stuff. I do like use many words. I cannot finish. Like, I did the question, but not
Yes,
finish.
I understand.
And I mean the good.
Because like I have been used to just like chapter 10 and then. But I have been manually just like I start and then just like because
I run like I think why, but I'm resting. I'm so tired.
Yes, go to sleep. Please. All right, cool. So what happens in the same equation when y is 2? Where will they intersect? Well, if y is 2, what do you add to 5 to get 2? Negative 3, right?
Yes.
So x got to be,
Negative.
1.
we've already got the negative, right? So they intersect at 1, 2.
This is true.
All right, what about this other equation? What happens with this equation when y is negative 2? Well, if y is negative 2,
It has to be negative
Bye.
7 over 3.
That's correct. Good job.
I'm so
You're cooking. Now let's check that same line, but when y is positive 2. When y is positive 2, what's x got to be?
smart. -1.
Excellent. Now there's one thing everybody forgets about, right? We figured out when like the red and green lines are intersecting these guys, right? These guys. But we didn't figure out where the red and green intersect themselves, right? So let's check these two. I didn't color coordinate very well, but basically we're saying when does this intersect this? Did you know that this is a elimination substitution problem? Right? Where they intersect? So do you want to use elimination or substitution?
I don't know the difference.
Elimination is you add or subtract them to make one of the variables go away. That's why it's called elimination. Or substitution is switching things out.
Well, I can't correlate words to the things.
Okay. So Mars, do you have a preference? Elimination or substitution to solve a problem like this. This is chapter 5.
I know this is
Okay, cool. Do you want to add or subtract to get rid of stuff?
add the 3x.
If we add them, we'll end up with 2y equals no x's plus 10. So that means y has to be what? Good. So y is 5. So one of our intersection points is at something comma 5, right? So if y is 5 for either of these, right? Y is 5 for either of these. X got to be 0. So they must intersect at 0, 5. So now we're going to maximize this thing. The whole point was to find all the critical values that can maximize and minimize this, okay? So what we're going to do is plug all these answers, these points into here, and figure out which one comes out the biggest and which one comes out the smallest. It's a lot of time. But this is actual like math in the real world. Like I have all these constrictions and I need to figure out how to like do the best possible move. This is that. This is called optimization. So if x is 0 and y is 5, what will this will end up being 5, right? So this gets us 5. I'm going to put a giant circle next to that. Okay, that's what we get. If x is -1 and y is 2, what do we get here?
-2.
We get -2. So right now our min is this guy and our max was that guy. But we got more to check. What happens if x is 1 and y is 2?
That would be 6.
Good. So now we have a new max, right? 1, 2 is better than 0, 5 apparently. Right? So instead of using all of y, we can do a combination. It's actually better, right? All right. Now we're going to plug these in, which are kind of annoying. What is 4 times 7/3? Now we just got to times them. What's 4 times 7/3? 28 thirds. And we're supposed to subtract 2, right?
Yeah.
So how many thirds is minusing 2? 6 thirds, right?
Yeah.
So this is really 22 thirds. That's a little bit more than 7, isn't it? So right now we have a new max. Surprisingly, this is actually a max. Having a negative for y, it was worth it to get more of x. Now, down here, we're going to get the exact same thing, except we're going to have some negatives. So we're going to get negative 28 over 3 minus 6 over 3, which is going to get us negative 34 over 3, right? So that's a little bit more than a negative 11, right? So we have our min and our max. Our max was actually this guy at 7/3 comma -2. And our min ended up being here, right? At negative 7/3 comma -2. Oops. I did. There you go. That is it. Stop smoking. We love you. All right. Let's go to 10 and then call it a day, huh? Although 10, you guys probably feel pretty good about.
You can say that.
All right. 10. This is what you guys got, right? Okay. We've got, it's only 5:07 right now. We are so ahead of the game. Guys, if you're not sure, you can always times by -5, and you end up with this, right?
Yeah. And then divided by 5.
What do you... No, pause. We times by -5, we get 25. What do you times by itself to get 25?
5.
Or...
-5.
Yes, this is an answer that is a plus or minus, right? Remember, we should get 2, it's squared. Thank you, Gauss. This, everybody gets confused on this. I'm going to show you one way that guarantees to get you out of the confusion. If I rearrange it, what common factor can I take out of these? And if I write it like this, the answers become a little more obvious. R has to be negative 13, or R is going to be 13 times 26 is not 0.
0.
0 times 13 is 0. These are our answers. All right, once you've seen it that way, can I show you a better way?
Yeah.
Do you see how negative 13 times negative 13 is negative 13 squared?
Yeah.
Obviously. Do you see how 0 times anything
Yeah.
is 0 times 0?
Yeah.
There you go. 70 times my number is equal to the square of my number divided by 5. This is a quadratic equation. We should get two possible answers. Let's go ahead and get rid of fractions by timesing by 5.
Oh, we did that.
It's an equation, dude. Why not?
Oh.
And then if we rearrange it, we get n squared minus 350n. What does this remind you of?
1.
It's literally just this again. Take out an n, right? So definitely there's two answers. One of them is 0. What's the other one? Because you can easily see it from here, actually. What's the other answer?
Negative.
0 times 0 equals 0 times anything. 350.
Yeah. But it was negative.
Yeah. Right, 350 times 350 equals 350 times 350. All right, here, let's rearrange this. Everybody doesn't like to rearrange these, and then they end up screwing them up. So if we subtract 18, you always want this to be positive if you can get away with it. It makes life so much easier, okay? So don't be moving that over to join the 18. Let's factor T and T. Dynamite. What else do we know?
That I don't know where that's from.
That's fine. It's a song by AC/DC.
You sing. I mean, I know that, but I don't know where it's from. Okay, can we just look? Don't we have to add to negative 3 and 18, so we gotta do what goes in 18, so it's 1 and 18.
If we're multiplying to negative 18, what does that tell us about the
It
signs?
has to be 1 negative and 1 positive.
Good. What number is multiplied to negative 18 and we'll subtract, because one of them is going to be negative, subtract to negative 3? Negative 6, positive 3. That means our answers will be negative 3 and positive 6. Yeah. All right, so let's rearrange this. Do not move the x squared over in order to make that negative. Let's factor. We know we need x and x. What else do we know? That's fine. I know. You gotta have double negative, because only two negatives will multiply to a positive and add to a negative. What numbers multiply to 36 and add to 15, essentially? Because, right, they're just gonna add up to negative 15. Thank you. Well, 1 and 36 doesn't. 2 and 18 doesn't. It's 12 and 3. X is 3 and x is 12. Hooray for factoring. Yay, Algebra 2. All right, next page. It says find the sum of the roots and the product of the roots. Fam, 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 fam. We could factor this, find our answers. Like this last one, the sum of our roots is 15, right?
Yeah.
And the product is 36. But you notice, like, you can do that without having to actually find these. It's where they came from. So the sum of our roots is always going to be negative b over a. Opposite sign, negative b over a. So b is clearly 5. So negative 5 over, and a is 1. So it's just negative 5, right? The product of our roots is always c over a, which means we get negative 176 for c over 1. So negative 176 in this case. Crazy stuff. Now, let's factor this thing. I love telling people, hey, just try it. What do we know? We need x and x, right?
Yeah.
How are we going to get m squared?
We're gonna do 2 and
We have to have m and m. Now, what do we know? M has to come out negative. Right now, it comes out positive.
so it has to be negative and positive.
Yes, and this actually takes care of everything. This is the right answer. Notice we get x times x,
X times x, and then
negative mx, positive mx goes away.
they'll subtract into each other, and then all I have left is
Exactly. So you nailed it. Well done, Kentucky.
Ready to work.
All right, here we go. These are harder because number in front of x squared, right? But let's rearrange this first. My camera's being stupid. Oh no, I'm sorry. Okay, so let's rearrange this. Notice I'm not changing any sides here, so I'm not changing any signs. I'm just rewriting it. It's all addition, right? Now, hopefully, all these numbers are divisible by 3, and our life is going to be golden. I have bad news. This is 8 away from 60. So 52 is not divisible. 51 is. I think yesterday we decided that this was impossible, even if this is 51, but let's double check because I was very tired yesterday. And I'm very tired now, but who knows? So it's got to be 3x and x, yeah? Has to be.
Yes.
And we're going to add to an odd number, so we need one to be plus, or one to be even and one to be odd. Right now, anything we times is going to stay odd unless there's an even here. So we need evens to make this happen. Is 147 even? No, so we're never going to find a way to do this, right? Because I would need like an even here to become out even, and an odd here to come out odd for a total of odd number here. So this is impossible, unfactorable. Now, technically, it is your job, and if you were taking Algebra 2 with me, it would be your job to find when it's unfactorable. So it's not like it's always guaranteed, right? There's no way to make this happen. Later, we're going to learn a technique that gets around this. It's a little bit messier. This is really good to be able to just like boom, 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 boom. And you need to know this because life is so much easier in higher level math if you can factor like a beast, right? But when it doesn't work, there's another technique. Those two things are basically all Algebra 2. All right, how can we make this easier? Multiply by 10 to move the decimal place over, but there's a better option.
Divide by 5.
That's not a terrible idea, but then we're going to get a fraction in front of this, which is kind of nasty. You could do it, though. All these are valid options. Let's just double it. Isn't doubling this going to get us negative 15t? And doubling this is going to get us 13? Right? So now we know we need 2t and t, definitely. It's the only way to make 2t squared. Do we need double positive, double negative, or one of each?
Double negative.
Dub negative. And 13, there's only one way to do it. 13 and 1. So where do we want the 13, you think?
Does it matter?
Well, if we put it here, we're going to double the 13.
You want the 13 where it's not
Exactly. Oh my God, everybody locked in this last week, and that's why this stuff is easy. This is one of the hardest chapters in previous classes for Algebra 1 and Algebra 2. Because we did it a little bit earlier than you guys in Algebra 1. No, we did it at the beginning of Algebra 2. That's what we've always done. And this kicks everybody's butt. And I think it's because they don't lock in.
Well, what you're saying is true, but if we get an even one, couldn't kick me.
In this class?
Yes.
Okay, because Algebra 2, if you're doing good with this, the rest of math life is going to be so easy for you. You'll be fine.
But that's also a joke. My mom's not a BC. Don't talk BCS.
You'll both be fine. I make lists of students that I'm worried about, and you are on the worried about list, but like it's because you haven't turned stuff in, and like if you get your crap together, there is nothing to worry about. Yes, both of you. Yes. Yes. If you get your crap together, there is nothing to worry about. There's some kids, they're like, I'm going to get my crap together, and it's still not going to be enough.
What am I not turning in?
Oh, big deal. Let's just do every problem. This was in general, right? The sum of the roots of a quadratic is negative 15. That means negative b over a must equal negative 15. Let's say a is 1, right? That means we have this. That means b must have been 15. We also know the product of our roots is negative 76. Well, that means this. Well, if a is 1, then c must be negative 76. So here's our quadratic. Now it says find the roots. So now we got a factor. We know x and x. What do we know about the signs?
That there has to be double and
Yep, that way we multiply to a negative. And we're going to add to an odd. So that means we need one of these to be an even number, right? Exactly one of them. So 76 has some options. Let's go ahead and write those down. 1 and 76. 35 plus 3, which is 38. But we're not going to use that. See how it's double even? Two evens will never add to an odd. So it's not that. What about 3? Does 3 go into 76? No, because it goes into 60, but not 16, right? What about 4? Yes, it does. We're going to get 4 and 19. That's a possible one. In fact, That's exactly what we need, isn't it?
Yeah.
Yeah.
We need positive 19 and negative 4.
You stole my line. I think you
Huh?
yeah, I said resist number.
Okay, cool. This thing. Let's rearrange it. Do not make this negative. Move over the 15. I wish we could divide everything by 13, but we can't. But 13 isn't that bad because it's got to be 13R and R. There's only one way to do that, right? What do we know about the signs?
Yeah, I'm still grabbing. I can't think until I'm done right.
That's fine.
Wait, no, my brain isn't working.
Oh wait.
Oh.
Yeah.
My brain hurts.
That's because you're using it.
Negative and a positive.
It's got to be one of each. I'm going to guess, but I could be wrong, that we want the positive here, right? That way we times by 13 something big, and we end up here. Notice we're multiplying to or we're going to add to an even number, which means we need 2 evens or 2 odds, okay? So that limits us. 15 is going to be 1 and 15 and 3 and 5. That is it. So notice if we do an odd times an odd, we get an odd, and this is going to be an odd times an odd as well. So we're going to do odd plus odd. That's what's going to happen, right? That's possible. Odd plus odd is even. So do we want 1 and 15? 15 here, way too big.
No. Yeah.
15 here, 1 there, way too small, right? So it's got to be 3 and 5. What do we want to times by 3? What do we want to put the 3 here or the 5 here?
3.
39 minus 5.
Yeah.
R is going to be negative 3. R is going to be 15 over 13, or 5 over 13. Who is still here? It's Friday. Go home.
They have like they wouldn't have basketball practice. It's not even different.
No, there's no basketball.
I just remember the last 2 times that I was here. There was basketball.
Yeah, that was last semester.
That was last.
So here I times by 6. Do you see why? It gets rid of all the fractions. Now, 6 kind of sucks because we have options, right? Notice 21 has only factors that are odd, right? 1 and 21, 7 and 3.
Yeah.
And we need to add to an odd. 2 odds will never make an odd. So we need 1 even, 1 odd. We need 6 and 1 or 2 and 3 to make that work. So the question is it going to be 6 or 1 and 2 and 3? I'm going to guess 2 and 3. Doesn't matter whether you write the 2 or the 3 first. Right now it's symmetrical, right? Do we need double negative or double positive? Or one of each? It's got to be one of each. Probably the negative over here, so we negate and times by 3. That'd be my guess. Seven and 3. Where do we want to put the 7? It's not 21 and 1, right?
Matt, could you explain to me that 6 squared plus 11?
Times by 6, times by 6, times by 6. 6t squared. 6 divides out. 6 divided by 2 is 3.
Oh,
Yep, there you go. Yep.
that makes sense.
No, good question. You have to ask those little questions
I
because,
wasn't looking at the screen.
yeah, yeah. And something that small would keep you from understanding all of it. So if you don't ask about tiny things like that, a tiny thing is going to stop you from understanding everything. And that is just not cool because you understood all this. You just missed that one thing. All right. If we put a 7 here, we're going to get negative 21 plus 6. That ain't it. If we put our 7 here and our 3 there, we get 14 minus 9. That ain't it either. Guess what? Nope, it's got to be 6. It's got to be 6t and 1. That's the other option. Let's check that. We're probably going to use 7 and 3, right? Notice if we put a plus 3 here, we get 18, and that's minus 7. That'll get the job done. T equals 7 over 6 and negative 3.
So I'm still right. It's unfactorable if you did that.
What? Oh yeah, with the 3 and the 2. Yeah, yeah. It definitely couldn't work with 3 and 2. It had to be 6 and 1.
I just forgot you had to make it.
Yep. All right. Last page. Yeah, last page before we get to the advanced. So consider this. When will this equal 0? What does x have to equal to make this part 0?
The fraction that gets rid of x and makes the other one negative.
Are you seeing this? Gets rid of a, negative b.
Yes.
What's the other answer?
The other one, I'm
That's fine. That's fine.
It would be negative. Yeah.
Yeah, this is just pointing out that pattern just in case you didn't have me as your teacher. That's like, guys, this is how we solve problems like this every single time, right? Divide that out, get the thing you want. Find the product of the roots. Isn't our product always C over A?
Yeah.
What's our C value here?
Negative
704.
4.
And what's our A value?
96.
Done. Find all solutions to this equation. I think this one has no solutions, actually. But that's okay. No solutions is an option. So here's the danger. We are going to square both sides of an equation. Always. When you square something, that makes it squared. And according to Gauss, if you square something, how many answers should you get? But was this squared originally? So how many answers originally should we have? So we're going to get, sometimes you're going to get 2 answers, and one of them isn't going to work. Okay? You have to go back and test it. Sometimes you get no answers, right? But in this case, when we square it, we're going to have some danger. So when I square this, I just get 7x minus 4, right? And when I square this, I do not get 9 minus x squared. What does it mean to square something? Mm-hmm. Yeah. Do you see how when we expand this, we're not just going to get 9 minus x squared. We're going to get 9 minus 6 x's plus x squared. Yeah, you can't just distribute squares, right? That doesn't work that way. You can't just like square individually. Are you guys seeing what I'm saying? 3 times 3, 2 negative 3x's, and positive x squared. All right, let's rearrange this. X squared. If I subtract 7x's, I'm at negative 13x's. And if I add 4, I'm at positive 13. So this is the equation we have to solve. We should probably do this by not quadratic formula. We should probably do this by factoring. But here's the thing. How many ways can you multiply to 13?
1.
Only one nice way. Does 13 and 1 add to negative 13? It'll never work. This is unfactorable. So what we're going to do is we're going to say that this is unfactorable, and we're going to move on. It has answers, but we cannot find them. I picked numbers that suck. So imagine we have found numbers, right? Let's say we found x equals, let's say 2, okay? If I plug in 2, I get 14 minus 4, so I get the root of 10. And this becomes 1. Pretend the root of 10 is 1. That worked, okay? What if I had another answer like x equals negative 5? Notice that this one would not work, not even if we pretend it makes it equal, because negative 5 times 7 is what? So we get the root of negative 39. Can you root a negative number?
No.
Not that you know. Algebra 2, right? So one of these would be extraneous, and you'd circle the other one, okay? Right? Extraneous meaning it doesn't actually work in the original problem. Whenever you square, you have the chance of that happening. All right, this last one, the sides of a square. Let's draw a little picture. The sides of a square are increased by 8 inches. So we're going from here to here. Let's call the sides x by x, okay? If I increase the sides by 8 inches, what are the new side lengths?
X plus 8.
You guys are so much better problem solvers than I ever was in high school. We had no idea what this meant, right? We could never conceive that, oh yeah, it's just x plus 8. That's the number 8 bigger than x.
Well, also you just teach in a way different.
I teach way different than what I grew up. All right, what is the area of this square right now?
X times x, so x squared.
Which is why it's called squaring. And then apparently the area is the same over here, but plus 144 inches. So this is the area over here, right? So what do we know? We know that x plus 8 times x plus 8 should get us x squared plus 144. You guys follow me? Right? So now let's distribute. And solve for the original side length, which is x. Do you see how x plus 8 times x plus 8 gets us x squared, 2 8x's, which is 16 x's, and 64? Because if you do, you're really picking this up quick. Right? 8x, 8x. Right? subtract these. Hey, look, we're only going to get one answer, which makes sense because there should only be one square that does this, right? And then if we subtract 64 from this, what we're going to get is 16x. We probably could have divided by 4 to everything. That would have been more efficient. We're going to get 80. Or no, not 80. No, it will be 80, won't it?
Yeah, 8.
So x is going to be 80 over 16. If you want, that simplifies to 20 over 4, which simplifies to 5. So the original side length was 5, and the new side length was 13. That's it, unless you want to do the advance. It is 5:30. Go home.
Even if we did, it probably wouldn't be.
We're going to review Monday and Tuesday in class, and I'm going to be honest. What's going to happen is we're going to do the exact same thing we did right now for everybody that didn't come here, and we'll do a lot of the basics and very few of the intermediates because that's all we'll have time for. So you're probably going to be a little bored. During that time, what you should do is you should try practicing these without using your notes, right? But looking at your notes if you're stuck. Yeah. Review time during class is going to be kind of useless for you too because of what we did here. But that's a good thing.
I didn't really finish my chapter 10 quiz.
That can work too. You can take quizzes during class. That'll work. All right, anyway, that's it. Goodbye.